Today's lesson is on recursive sequences. A recursive rule gives the beginning term or terms and an equation that gives the next term. So here's what I mean. A sub n could be any random term. A sub n plus 1 would be considered the next term, and n minus 1 would be considered the previous term. For example, let's say n is 6. Then this would be 6 plus 1, which would be a sub 7. And if n is 6, that's 6 minus 1, which is a sub 5. So notice if you start with a6, 5 is previous, 7 is next. So this is just another way of defining terms. Another way of saying previous term or next term. Okay, so you'll get the hang of it once we do a few examples. So let's write the first 6 terms. So we would have A1, A2, A3, A4, A5, and A6. So it says A sub 1 is 2. And now we're going to look at the rule. Now, you have to have something to start with. And for this one, we just needed one term since this is based on the previous term. Remember, that means previous term. Okay, so now if we want to know the next term, which happens to be a sub 2, if you were to plug 2 in here, 2 minus 1 is 1. So this is saying plug in a sub 1. But you can make it easy on yourself and always just plug in the previous term. So this is saying for a sub 2, this is saying 3 times the previous term plus 2. So that would be 6 plus 2 is 8. Now, if we want to know a sub 3, it's going to be, if you were to place 3 in for n, 3 minus 1 is 2. So this term is going to be based on a sub 2. So to find a sub 3, we're going to say 3, looking at this 3, times the previous term, which is 8, plus 2. So that's 24 plus 2 is 26. Okay, so we're always just looking at the previous term to plug in here. I hope that makes sense to you. So now I'm looking at 3 times what? The previous term, which is 26, plus 2. So that's going to be 78 plus 2 is 80. And now we're going to plug in 80. So for a sub 5, 3 times 80 plus 2, that's 240. And 2 gives me 242. And now we're going to find a sub 6, and we're going to plug in a sub 5, which is 242 times 3 plus 2, which is, let's see, 726 plus 2 is 728. So, recursive rules are always based on the previous rule. Now, what I really don't like about recursive rules is, like, say I want the 100th term, I would have to find all 99 terms before it. There's no way to use a recursive rule to skip around. That's why I personally prefer an explicit rule. Later in this lesson, I'll show you how to translate that to an explicit rule. Sometimes you can't, though. Sometimes things can only be defined recursively, but most can be converted to an explicit rule, and we'll talk about that. Okay, so like I said, I prefer an explicit rule because I can just plug in. And it's based on the term number. For example, if you want to know a sub 100, you can just plug 100 in. That would be 300 plus 1. So it's easier to me, at least the way my mind works. Also, remember we have different types of explicit rules. They can be arithmetic or geometric, and there are others out there that are neither, but still can be defined explicitly. For example, a sub n equals n squared. That's not geometric and that's not arithmetic, but it's still an explicit rule where you can actually plug in a value for n. Now, recursive rule, it's always based on previous terms. Sometimes it can be based on the previous 2 or 3 terms. If that were the case, you'd have to give more beginning terms up here just to get you started. But that's the difference in a nutshell. Example 2, for the sequence 3, 6, 12, 24, we're going to define it explicitly and also recursively. Before we can do that, let's see what's going on. That's going up by 3, up by 6. That's not a common difference, but I can see we're multiplying by 2. So this is geometric and it has a ratio of 2. Now that we know that, we can use our geometric a sub n formula. So a sub 1 is 3 and r is 2. So this is defined explicitly. If I want to know the 8th term, I plug 8 in for n and boom, I get an answer. But let's see how we could define this recursively. We're going to look at what's going on. We're multiplying the previous term by 2. So if you need the previous term, you have to give the first term. So I would say a sub 1 is 3. And then I'm going to say multiply the previous term by 2. How do you say previous term? A sub n minus 1. So if I want to know what the next number is, all I have to do is multiply 24 by 2, and I would get 48. So it's just the previous term. Okay, and that's how you define that recursively. Example 3, write a sub n equals 3n minus 4 recursively. Now you can tell if something is recursive because you see that little subscript with the minus 1 on it. So this is explicit, and now the directions say, let's write it recursively. So what I like to do is write the first few terms so that I can see what's going on. So if I plug in 1 to figure out what a sub 1 is, that would be negative 1. So my first term is negative 1. My next term, I'm going to plug in 2. See, remember when it's explicit, to write your sequence, you just start with 1 for the first term, 2 for the second term, 3 for the second, so forth and so on like that. 6 minus 4 is 2, so the next term is 2. 9 minus 4 is 5. And already, I hope that you can see what's going on. Remember that notion of slope? And this is linear. So we can see that it's just going up by 3. It has a common difference. So now, if I would like to define this recursively, I have to at least give the first term. which is -1. And now all we're doing is adding 3 to the previous term. So I'm going to say previous term plus 3. Okay, that's how you do that. And that would be a recursive definition. You give the beginning term or terms, and then you explain what to do to the previous term to get the next term. Okay. Example 4. Write an explicit rule for this recursive sequence. So now we're going the other way. We have a recursive rule, and now we want to find the explicit rule. So if we start off by writing a few terms just so we can see what it looks like. Remember, this is saying plug in the previous term and add 4. So the previous term here would be 7, and 7 plus 4 is 11. The next term would be defined by 11 plus 4. You always just add 4 to the previous term. Okay, so that's what's going on here. Now, we can see that we have a common difference of 4. So this is arithmetic. So you can use your arithmetic A sub n formula, which is A1 plus n minus 1d. I hope you have all 5 of your formulas written down on a sheet. Makes it a lot easier. So A sub n is going to equal A1, which is 7, plus n minus 1d. D is 4. And we simplify and get 4n plus 3. That would be an explicit rule for this recursive. At first it was recursively defined, and now we've defined it explicitly. Probably the most famous recursive sequence there is the Fibonacci sequence. And some of you may be familiar with it. Let's see if you know what the next 3 numbers are. Think about it for a moment. Look at the pattern. Okay, if you do, write those numbers in. What's going on is that we're adding the previous 2 terms. So 1 plus 1 gives us 2. But 1 plus 2 gives us 3. And then you always just add the previous 2 terms. 2 plus 3 is 5. So to get the next term, I would add 3 plus 5 to get 8. 5 and 8 give me 13. 8 and 13 give me 21. And you can do this forever. There's no end. But now I'm asking you to define the Fibonacci sequence recursively. Whenever something says add the previous 2 terms, you have to give the first 2 terms just to get started. So I'm going to say A1 is 1 and A sub 2 is also 1. Now, remember that A sub n, the previous term is A sub n minus 1. What do you think the term before that would be? A sub n minus 2. Okay, if you go back 3 terms, that's A sub n minus 3. So here we're saying add the previous 2 terms. So that would be A sub n minus 1 plus A sub n minus 2. Or you could mix that order up. It doesn't really matter. Alrighty, so that would be our recursive definition for the Fibonacci sequence.